Welcome back to the channel, and we were asked to find the derivative of this function. And when you look at this function, you discover that this is a rational function. And when you have rational function, the best way to go with it is quotient rule, right? If you are doing the derivative. So, what does quotient rule say? Quotient rule say d over the x, say du over v equals the product of v and u prime minus the product of u and v prime over v squared. So let's go into it. We can say now let u be equals to what? S squared, our numerator, and u prime equals 2x. So the derivative of x squared is 2x. So we also find, we say v equals to the denominator, which is x plus 1, and the derivative of x plus 1 is 1. So what we are going to do now is to substitute this into our quotient rule. So we now say y prime. We now be v is x plus 1, then multiply by u prime. U prime is 2x rather. Then minus, what is u? U is x squared. S squared multiply by v prime. V prime is 1. Over, we have v squared. So v squared will be x plus 1 squared. So what we just need to do is to expand this. So I have y prime equals x multiplied by 2x is going to give you 2x squared. 1 multiplied by 2x is going to give you plus 2x. So now I have x squared multiplied by 1 is going to give you negative x squared. And all to x plus 1 power 2. So this we can still simplify this further because we have 2s squared minus 1s squared. So you will have x squared then plus 2 plus 2x over the denominator, which is x plus 1 squared. Remember, this is y prime, which is the differential. So the next thing we can still simplify this to be y prime to be, we can factor out common is x plus 2 over x plus 1 squared. And that is how to find the derivative of that rational function.